Today, I'm going to show you how to blink an LED in Tinkercad using an Arduino Uno R3, step by step. This is one of the best beginner projects because it teaches you the basics of circuits, digital pins, and simple coding all in one place. By the end of this video, you'll have a working blinking LED and you'll understand exactly how it works. If this tutorial helps you out, make sure to hit the like button and subscribe for more easy electronics and coding guides. All right, let's jump right in. First, open Tinkercad and start a new circuit. Once you're inside the workspace, go to the Components panel on the right side of the screen. From there, drag an Arduino Uno R3 onto the canvas. This is going to be the brain of the whole project, because unlike a battery circuit, the Arduino lets you control when the LED turns on and off using code. Now drag in two more parts, an LED and a resistor. The resistor is very important because it protects the LED from drawing too much current. Click the resistor and change its value to 220 ohms. That's the standard value most people use for a simple LED blink circuit, and it works perfectly for this project. Next, let's build the circuit. We're going to use the Arduino's programmable pins instead of a battery. Start with the positive path. Click on Digital Pin 13 on the Arduino and draw a wire to one side of the resistor. Then connect the other side of the resistor to the anode of the LED, which is the bent leg. This is the side that receives power. Now for the negative path. Click the GND pin on the Arduino and draw a wire to the cathode of the LED, which is the straight leg. This completes the circuit and gives the electricity a path to flow back to ground. Once those connections are in place, your hardware setup is ready. If your wires look a little messy, don't worry. In Tinkercad, the important thing is that the correct pins are connected. Just double-check that pin 13 goes through the resistor to the LED and that the other side of the LED goes to ground. That simple layout is all you need for a blinking light. Now it's time to open the code editor. Click the Code button in the top right corner. By default, Tinkercad usually starts you in blocks mode, which is great for beginners because it works a lot like Scratch. In many cases, you'll already see a pre-made blink program waiting for you. If you do, that makes things even easier. If the workspace is empty, don't worry. You can build the blinking logic using a few simple blocks. First, set the built-in LED to high. That turns the light on. Then add a wait block for 1 second. After that, set the built-in LED to low, which turns the light off. Finally, add another wait block for 1 second. This creates a repeating on and off pattern. What's happening here is actually very simple. The Arduino is powering the LED for 1 second, then stopping the power for 1 second and repeating that over and over. That's what makes the LED blink. It's a great first example of how code can control physical hardware in a very precise way. Now, before you start the simulation, make sure everything is connected properly one more time. Check the resistor value, verify the LED direction, and confirm that the wires are attached to the correct pins. Once you're confident everything is right, click Start Simulation. As soon as the simulation begins, the Arduino will power up virtually, and your LED should start blinking on and off every second. You may also notice the little L light on the Arduino board itself blinking too. That's because pin 13 is special. It's internally connected to that built-in LED, so when you program pin 13, both your external LED and the onboard L light respond together. That makes pin 13 a really popular choice for learning because you can see the effect both on the breadboard and directly on the Arduino board. It gives you instant feedback and helps you understand how the code matches the hardware. If you want to change the speed of the blink, that's easy too. Just adjust the wait blocks. For a faster blink, change the wait time from 1 second to 500 milliseconds, or even 0.2 seconds. For a slower blink, increase the delay to 2 seconds or more. Small changes like that let you control exactly how your circuit behaves. And that's it. You've successfully built a blinking LED circuit in Tinkercad using an Arduino Uno R3. You added the components, connected the circuit, opened the code editor, and ran the simulation. That's a huge first step into electronics and coding. If this video helped you, please hit the like button, subscribe to the channel, and turn on notifications so you don't miss the next tutorial. Thanks for watching, and I'll see you in the next one.